One of your classmates came to office hours and she asked some really good questions. And one of the things she was concerned about was like, we've learned so much stuff in this chapter. It's so many different ways of taking derivatives and different types of derivatives. And like, how did she keep it all straight in her head, especially with word problems? So we worked a series of derivatives that really helped her, and I thought it might help you too. So what I've done here is I've created a price demand equation. So X is demand, P is price. And we're going to use this equation over and over and over again, but you're going to find the derivative based on different given information. And that given information is going to change the context of the problem, and it's going to change what type of derivative you're taking. So let's just take a look. Okay, so here's our first derivative. We're being asked to find the rate of change of demand if X is a function of P. So rate of change of demand. They are asking us to find X prime. So we're being asked to find X prime if what? Well, if demand is a function of price, what does that tell us? That tells us that in this scenario, the letter P is a variable. So that means if you take the derivative of P, it's going to be 1. And the letter X is a function. So if you take the derivative of X, it will not be 1. You'll just record it as X prime. So let's go ahead and do that. We're going to rewrite our equation. So X equals 10 plus 500P minus 0.1P squared. And I'm going to take the derivative of both sides of every single piece. And when I see an X, I'm going to treat it like a function. And when I see a P, I'm going to treat it like a variable. Okay, so here's our first piece, X. The derivative of X is X prime. And since X is a function, I will not turn that to a 1. I'm going to leave it as X prime. Now moving down the line here, the next piece is a constant. The derivative of a constant is always 0. For my next piece, 500p, I'm going to use my power rule. So I have an understood exponent of 1. I drop the exponent down. 500 times 1 is 500. I rewrite my base, p. I decrease the exponent by 1, so now it's a 0, and I tack on the derivative of the base. And I can clean this up a little bit, right? Because I know that p to the 0 power, any non-zero base to the 0 power is just going to be a 1. And I also know that p prime is a variable, so the derivative of p is also just going to be a 1. So if I do 500 times 1 times 1, I'm just going to get 500 there. So X prime is going to equal to 0 plus 500 when I multiply all that together. Okay, I still have another term here. So let's go ahead and oh yeah, we need a power rule again. So I'm going to drop my exponent down to the front. So that'll give me negative 0.1 times 2 is negative 0.2. I rewrite my base p. I decrease that exponent by 1, which would be, oh, now my exponent would be a 1, but we don't write that because it look like a prime, so that's just understood. And then I tack on the derivative of the base. So for that term, p prime is going to be a 1, right? Because p is a normal everyday variable and the derivative of a variable is 1. So I can simplify this term to just negative 0.2p. Okay, so if I take the derivative of X, where X is a function and P is a variable, the derivative is just going to be 500 minus 0.2p. Okay, but what if the conditions change? Same equation, different conditions. Let's take a look. So same price demand equation. I still want you to find the rate of change of demand. So I still want you to find X prime. But now I've told us that X is a function of time and P is a function of time. How does that change the derivative? Well, now t is the input variable, so the derivative of t would be 1. But x is a function, so the derivative of x would not be a 1. And p is also a function, so the derivative of p would also not be a 1. Okay, so same equation. I'm still taking the derivative of every single piece on both sides. So now when I take the derivative of x, that's x prime. X is a function, so I'm just going to leave it x prime. When I take the derivative of 10, 10 is a constant, so that's derivative 0. When I take the derivative of 500p, I'm going to do my power rule, but p is a function. So understood exponent of 1 times 500, that'll give me 500. I rewrite my base. I decrease my exponent by 1, and I tack on the derivative of the base. Now, p to the 0 power is still going to be 1. Any non-zero base to the 0 power is going to be 1. But p prime is not going to be 1 because p is a function. So p prime not equal to 1. So when I rewrite this, I'm going to get x prime equals 500 p prime. Okay. And now let's go to this last term. I'm still going to do my power rule. I drop my exponent down. So negative 0.1 times 2 is negative 0.2. I rewrite my base. I decrease the exponent by 1, so that exponent becomes an understood 1, and I tack on the derivative of the base. And again, p prime does not equal 1. So when I go to record this, I'm going to just keep it minus 0.2 p prime. So that's what x prime would look like if both x and p were functions. In this case, they're functions of time. Okay, well, let's change up the conditions again. What if I gave you the exact same price demand equation, but now I ask you to find the rate of change of price? So that's a p prime, rate of change of price. So now you're being asked to find p prime. And we're told that p, price, is a function of x. Price is a function of demand. So what does that tell us? Well, from reading the notation, I can see that x is the input variable. So if I take the derivative of x, it's going to be 1. The derivative of a normal everyday variable is 1. And p is a function, so the derivative of p would not be 1. I'll just record it as p prime. So same equation, I still take the derivative of every single piece on both sides. So x, derivative of x is x prime, but x is a variable, so the derivative of x is just going to be a 1. So I'm going to really record that as 1 equals. 10 is still a constant, so the derivative of a constant is 0. For the next term, I still need my power rule, so I drop the exponent down. 500 times 1 is 500. Rewrite the base, decrease the exponent, tack on the derivative of the base. P to the 0 power is still going to be 1. But p prime is not going to be 1 because p is a function. So I'm going to record that term as 500 p prime. Okay, minus our last term here, still going to use our power rule. So I drop my exponent down. Negative 0.1 times 2 is negative 0.2. I rewrite the base. The exponent decreases to 1. I tack on the derivative of the base. And again here, p prime is not going to be a 1 because p is a function. So I'm just going to record that piece as negative 0.2 p prime. Okay, now remember, we're being asked to find p prime, right? We're being asked to find p prime. Right now, p prime is in 2 locations. So I need to factor out a p prime, right? So I'm going to factor out a p prime here. So when I factor p prime out of the first group, that leaves me just with a 500. And when I factor p prime out of the second group, that's going to leave me with a negative 0.2 p. And then p prime is isolated in one location. I just need to get it alone. It's currently being multiplied by this binomial, so I need to divide both sides of the equation by this binomial. And that gives me that p prime is equal to the fraction 1 over 500 minus 0.2 times p. And we're done. We found p prime. Okay, so the purpose of this series of derivatives was to help you train your brain to look at the given equation, go through every single letter and ask yourself, is this letter acting like a variable? If yes, the derivative is 1. Or is this letter acting like a function? If yes, then we just record it with a prime. It's not going to be a 1. And the way you get that information about variables and functions is by reading that extra piece of information, that extra function notation you're given. That function notation will tell you what's the input variable, what's the function. Okay, so slow your brain down, write it out, write all of that out before you take the derivative. That way later when you're taking the derivative, if you get lost, you can be like, oh, this letter was a variable, the derivative's just 1, or this letter was a function, the derivative is not 1, record it with a prime. So stay organized, slow your brain down, write down all the information that you are reading from the problem in words as reference. You got this, guys.